Okay, our mechanic is pretty close, but we're still missing one more thing. We have our sounds, but we want particles. And we want our tasks to be pretty modular and independent. I want to show you how to build things so that you can use them in other state trees beyond this tutorial, and playing particles is a pretty common one. So we're going to make a spawn particle task, and it's going to be very similar to how we did our sound, we're going to be able to spawn it attached, destroy a transition or whatnot. So the pattern will look very familiar, but I'm going to go through it because it's just so useful to know how to do. We're going to create some generic particles for prototyping. We'll just keep the defaults, and then you could use other tutorials to make them look nicer. We're going to do our enter exit functionality on our task, which I guess we'll need to make our task first. So create particle task with maybe our variables. And then we are going to, let's set up particles on weighted platform, and then play particle tasks on state tree. So it's usually good to just make a list of things to do in plain English so that we can stay on track. All right, so first we're going to make our default particles. I'm just going to make a generic omniburst and a generic fountain, like a looping particle emitter. Like I said, you can replace them with something nicer later on. For this tutorial, I just care about playing them appropriately. So content, let's make a new folder, particles. And in here, we're going to make a right-click Niagara system. This first one will be a omnidirectional burst. Scroll down to omnidirectional, create. We'll call this FXS for FX system underscore generic burst. Control S to save. We'll make another one, right-click Niagara system. This one will be our fountain, create. Call this FXS underscore generic. I don't know, let's call this fountain. Control S. Okay, so we have our burst and our fountain. One is a one shot, the other is looping, so that'll be useful for our prototype. Next, we want to create our task. So let's go to our state tasks. Let's right click blueprint class. This should all be review for you at this point. State tree task blueprint base. Okay. STT underscore spawn particles. Control S to save, open it up. Then we're pretty much going to make the same things that we did for our spawn audio task. So for variables, we want our context. So we'll call that actor. Make that actor object reference, and make sure the category for this is context with a capital C. We'll make another variable, particles to spawn. Make this Niagara system for our particle system. We will compile save for the category. This is going to be required. So we'll make this an input and compile save. We want the ability to attach or deactivate. Let's hit plus and say is attached. We'll make that a Boolean. We'll do editable because we want the designer to be able to optionally define that, and compile save, and the default we want to be true. So by default, it is attached, but maybe we want the burst to just stay in the world somewhere and not follow the actor. That could be possible too. And the last thing we want is add a new variable for deactivate on transition. Okay, Boolean, yes, we want the designer to define that for editable, compile save, and default to true. One last compile save. We have our variables, we have our generics, just need to add the functionality. So for our functionality, we want to do something very similar to our spawn sound, so you can look to this for review, but same thing, just slightly more complicated because our spawn nodes are a little bit more complicated. So we're going to override our EnterState. First thing we're going to do is check the validity. Again, probably unnecessary, but it makes me feel better. So I'm going to do it, and it's generally good practice. Is valid. Okay, a little question mark here. You could do a validation node, but I'm going to do it this way. Okay, is valid. And if so, then we want to check if we're attached or not. So drag in get is attached, because this will decide how we spawn it. So drag off and branch. If we are valid. So if true, then we want to spawn it attached. If false, you want to spawn it in the world. So we're going to start with attached first. So if we're true, then we want to spawn system attached. So underneath Niagara, spawn system attached. Okay, so there's a lot of settings here. One thing I want to point out that I do want to mark auto destroy in this case. If it's not looping, I want it to auto destroy, and that's not the default, so I'm going to mark that. And the system that we want to spawn, drag in our particles to spawn right there. Again, we need to give it everything it needs to do its job here. So not everything is required, but some things are. So spawn this system. And if we want to attach it to a component, we need to get the root component, just like we did before. That is a function. We're going to get the actor. So get actor, pull off, and get root component. I want to show you that if we tried to drag into it, it would tell us, hey, what are you trying to do here? And we could try to search to find something, get parent component and so forth, actor, right? Get root component. That's how you can figure out, your options if you want to do it that way. But it's pretty common to just get root component this way. So that's why I'm doing it. Okay, plug in our component that we want to attach to. Attach to point. We don't really need to worry about that. Now location. Okay, so this is interesting. For spawn system attached, I believe the location is relative, meaning that we're spawning it to our weighted platform 0, 0, 0 underneath default scene root. But if we did want to move this around, like start at the location of the actor and then move an additional XYZ, then we could. And so maybe we leave that as an option, but this would be called an offset. So let's give the designer the ability to add an offset to the location that they're getting spawned. So this is our 0. I'm pretty sure this is how it works. I'm not 100%, but I'm pretty sure. So we're going to right click, promote to variable right here. It calls it location. I'm going to relabel this offset. So if we want to add an offset, and let's make this instance editable too, then the designer can. When they spawn the particle, maybe they want it to spawn 100 units above or below or whatever, they can mark that there. All right, so we'll pull that out. So we have our offset for an adjustment for where we move the particles. And then a rotation, we'll just allow them to choose a rotation instead of 0, 0, 0. So we will right click, promote to variable. We'll keep that labeled rotation. Compile, save, 0, 0, 0 default, 0, 0, 0. Okay, perfect. I think that's it. So then after we spawn it, we want to, let's promote the variable, the return value, and we'll call this spawned particle because we want to be able to destroy this later on. So compile, save. Since we're auto activate, it should play automatically, so we don't need to play it. And I think we're good there. We need to spawn in the world if it's not attached. So let's do that. So drag off of false, spawn system at location. So the particles we want to spawn, we'll drag that in. It's our system. Now this is interesting. The way I believe it works is with attached, I believe our location is local, like an offset, how we have it set up. But for spawn system at location, we need to give it a location. Now we could give it our actor's location, right? We could just plug in the location of the actor. So if we get our actor, and then we get actor location, then we could just plug that in directly, but then it's going to behave differently depending on whether we're attached or not. And I want it to still have an offset. So a way to do that is we can take our actor location and add our offset on top of that and plug in the result to spawn system at a location in the world. So it's just the way that it's set up. It's asking for two different things here for location. So we're just calculating our own offset by getting the world location, right? So this location, and then add our offset if we have chosen one, so we can move it up off of this. But to do that, get our actor location, type add, we will do add, and then whatever we have defined for our offset, plug that in. So we're adding our world location by an amount, which is default at 0. So, a lot of times that'll be nothing. And the result will be our location. So this is just how we can calculate an offset very quickly. So plug that in. And then we also need our rotation. We'll plug that in. And I think that'll be it. Let's drag our rotation. Auto destroy, make sure that that is checked. I think the last thing is we need to save the reference like we did up here. So I will drag my spawn particles set, plug it in. So we're setting it into this variable reference, use it later for destroying. Okay, I think that's it. That was quite a bit. Pull that down. Now we want our exit state. We're going to check to see if we need to destroy it? And then if so, we're going to destroy. And actually, we're going to deactivate it so that the particles finish out their lifetime and then disappear instead of just instantly disappear. Deactivating a particle is a lot cleaner than destroying it, which will then auto-destroy once it's deactivated. Okay, so off of exit state, we want to check if we have marked our deactivate on transition. So get, we will check it. So branch, pull that up, pull it in. If true, then we want to see if our particle system still exists. So we're going to do another validated get. We're going to pull in our spawned particles get, right click and say convert to validated get. So we're going to get the particles, plug in our true. And if it is valid, then we're going to deactivate it. So if this is valid, then use our spawned particles that are now guaranteed to be valid, deactivate. And then if is valid, plug it in, use these particles, deactivate them. Let's compile and save. And that should be all of our functionality to make our modular task that just spawns particles when we need them. So now, just like before, we want to define the different particles that we want to use in our states on our weighted platform. So open up our blueprint and we'll make some variables for particle systems to reference in our state tree to play. That way we can customize them on different types of weighted platforms. So let's go over here under our syncing. Actually, let's just make a new variable. We'll call this start sync particles. We'll make one particle as soon as we step on the platform to cue to the player that something's about to happen. The type is going to be Niagara system, our object reference, and let's put the category for that under syncing. So our start sync particles, let's compile, save, and our default, we want to be our generic burst, right? So just a little burst of particles. Again, you could make a different one from other tutorials and just plug it in right here if you want to change it. I'm going to Control D to just duplicate it, just a little quicker. And let's make an end sync particles since we have our special child state. Once we're done syncing, where we hit here and wait, we will just make an end sync particles there as well. I think it'll be nice. Again, compile, save, and we'll keep that as a burst as well. And then we want our looping. So let's Control D again. So click Control D. We'll call this syncing particles. And this one we want to be our loop. So compile, save, so we can see our default. We'll change this to our generic fountain loop. Compile and save. All right, so we have our 3 particles for syncing. Let's make our particles for rising. Going to Control D, duplicate our start sync particles and drag it under rising. F2 to rename. We'll call this start rising particles. Compile, save, and that's going to be our generic burst. Again, we're just reusing this for prototyping. Click and Control D, and this will be our rising particles. Compile, save, and change this to our generic fountain. Compile, save one more time. I think we have all of our particle defaults set up. So this will be our customized particle data on our weighted platform. And the last thing to do is to actually play these particles in our tasks on our state tree. So we know what we need to do. Let's go to our start sync, add a task, just like we did with our audio. And we want to spawn particles. It's asking which particles do we want to spawn. Well, whichever ones are defined in our context actor, which will be our start sync particles. So we can choose if we want this to be attached or not. I'm going to say don't attach and don't deactivate on transition. Again, I'm just trying to find different combinations to test our task to make sure we did it right. For our offset, I don't really need to set an offset. We'll keep this one at 0 and then we'll do a different offset for our end sync one. Okay, that's our start sync burst. Our movement is our looping. So we're going to add spawn particle task. So choose our particles to spawn on our actor, our syncing particles. We do want this to be attached and we do want this to deactivate our particle loop whenever we switch to a different state. Offset, we can keep this again, compile, save. I'm noticing that we didn't mark our rotation. So let's come back to our rotation, mark that as editable. I'll probably want to use that a little bit later. So compile, save. And now we can put in a different rotation if we want. So I'm not going to, but I could. And then for our wait, this is when we stop our sync. We actually don't have a sound for this. We could add an additional sound if we want, but I do want a spawn particles. And when we hit the end of our sync, when we're waiting at the bottom, and for this one, let's do this attached, but not deactivate. it doesn't really matter at this point since it's going to be a burst. And then we'll go to end sync particles. And for this one, let's use our offset and we're going to play it slightly below the platform. So let's move it down by 50 maybe. Compile, save. You don't have to do this. I'm really just trying to test my different variables to make sure that they're functioning as intended. Okay, so next for our rising, let's play our burst. So you can see because we don't have our child states, we're putting a lot of tasks on this one state, which is a sign that we might want to start breaking this out into child states. But I'm not going to do that because we've already looked at how to do this in syncing. So you could do that if you want the extra practice. Okay, so let's add our spawn particles, our start, rise, burst. So it'll be our particles to spawn right here, actor, start rising particles. And for this one, what did we do before? We did nothing. Okay, so for this one, we will do yes is attached and no deactivate. Doesn't really matter. We'll leave the other defaults. And for our loop, let's actually test out a rotation. For our loop, let's do one more task. Spawn particles, and we're going to play our actor rising particles and is attached, yes, deactivate. And for this one, we're going to rotate it by 180 degrees. So the fountain, instead of going up, will go down. And I think that'll look nice because since we're rising, it'll look like we're pushing particles down beneath us. So just to test our rotation, we'll do 180 in the Y, which will be rotated downwards. Compile, save, and I think that's it. I'm really just trying to show you a couple different ways that we can spawn these particles and test our variables. You can always customize them slightly differently if you like. So let's test it out, hit play. All right, we should see a burst when we start, a loop when we start syncing, and then a burst at the bottom. And that one actually played above. Okay, I should have gone -50, but we at least see that the offset is working. And then if we step off, we should see a burst, and then we should see the fountain rotated downwards. Okay, perfect. All right, this is feeling pretty good. Only thing I want to fix is that burst. We hit the bottom. I don't want that to be above. I want that to be below. And honestly, I think that's going to be too far anyways. So what I mean is, right here we did +50. We actually want that to be probably like -20. And we'll test it one more time just to be sure. Should see it below, which might even be inside the floor, so we might not even see it. So let's see. Okay, right below. And that's just to show you that you can use an offset and make it look a little bit nicer. But for now, these are just generic particles anyways, so you would expect to replace those eventually. And the nice thing is to replace those, the FX designer just comes over here and, replaces this with the new one that they made. And they don't have to mess with any state trees or anything. So this is all coming together. I think this is all I want to do for particles, and it's looking pretty nice. And I did want to call out that I also did not, just like our sound effects, I did not finish my task. And that is because for sound and particles, I don't want that to trigger any transitions. I just want to play those very quickly and, all throughout without it interrupting my state flow.